Hi, I'm Bob. Welcome back to the Introductory Econometrics course. We will continue solving the computer exercises for Chapter 15, Instrumental Variables Estimation and Two-Stage Least Squares. Let's do computer exercise 5. In Part 1, in Table 15.1, the difference between the IV and OLS estimates of the return to education is economically important. Obtain the reduced form residuals mu2 hat from the reduced form regression education on near C4, experience squared black SMSA South SMSA 66, Reg 662 to Reg 669. Use this to test whether education is exogenous. That is, determined if the difference between OLS and IV is statistically significant. We estimate the reduced form equation for education by regressing it on all exogenous variables and then obtain the reduced form residuals mu2 hat. After that, we add mu2 hat to the structural equation and test for the significance of mu2 hat using an OLS regression. The coefficient on mu2 hat is not statistically significant at the 10% level. We could not reject the null hypothesis that education is not correlated with the error term in the structural equation. In other words, the education variable is exogenous in the structural equation after controlling for the other explanatory variables in the model. OLS is more appropriate in this case. In Stata, we can use the command estat endogenous to perform the test of endogeneity. We type the command directly after the two-stage least squares estimation. We get the same conclusion. In Part 2, we estimate the equation by two-stage least squares, adding near C2 as an instrument. Does the coefficient on education change much? We estimate the equation by two-stage least squares with one additional exogenous variable and store the results. Then we estimate the same equation by two-stage least squares with two additional instrumental variables. We compare the estimates in the table. The two-stage least squares estimate using two IVs is larger than that using one IV, and it becomes more statistically significant. In Part 3, we test the single over-identifying restriction from Part 2. To test the over-identification restriction, we first estimate the structural equation by two-stage least squares and obtain the two-stage least squares residuals mu1 hat. Then we regress mu1 hat on all exogenous variables and obtain the R-squared. Under the null hypothesis that all IVs are uncorrelated with mu1, n times R-squared follows a chi-squared distribution. In our case, n equals 3010. n times R-squared is 1.25. The p-value is 0.26. We could not reject the null hypothesis. The two IVs pass the over-identification test, and we conclude that there is no evidence that some IVs are endogenous. In Stata, we can use the command istat_overid to perform the test of over-identifying restrictions. We obtain the same conclusion. Let's find answers to computer exercise 6. The variable murder rate is the murder rate, that is, the number of murders per 100,000 people. The variable exit is the total number of prisoners executed for the current and prior 2 years. Unim is the state unemployment rate. In part 1, how many states executed at least one prisoner in 1991, 1992, or 1993? Which state had the most executions? We find 16 states executed at least one prisoner from 1991 to 1993. We find that the maximum value of execution is 34, and the state is Texas. In part 2, using the 2 years 1990 and 1993, do a pooled regression of murder rate on D93, execution and unemployment. What do you make of the coefficient on execution? We estimate the model with pooled OLS. The estimate of the coefficient on execution is positive and statistically insignificant. The estimate suffers from omitted variable bias. In part 3, we use the changes from 1990 to 1993 only for a total of 51 observations. Estimate the equation by OLS and report the results in the usual form. Now, does capital punishment appear to have a deterrent effect? The estimated first differencing equation is as follows. The estimate of the coefficient on execution is minus 0.104 and statistically different from 0 at the 5% level. One more execution in the past 3 years is estimated to lower the murder rate by 0.1. In other words, 10 more executions are estimated to reduce the murder rate by about 1 murder per 100,000 people. The capital punishment has a deterrent effect. In part 4, the change in executions may be at least partly related to changes in the expected murder rate, so that delta execution is correlated with delta mu in part 3. It might be reasonable to assume that delta execution in the past period is uncorrelated with delta mu. Regress delta execution on the first leg of it to see if they are sufficiently correlated. Interpret the coefficient. We regress the change in execution on the first leg of it and find that the slope coefficient is statistically significant. We can add the change in unemployment to the model and estimate the reduced form equation for delta execution. It is the first stage in the two-stage least squares. It does not change the conclusion that the changes in executions are correlated. The estimate is minus 1.1. It implies that the number of last period's executions is negatively associated with the number of current executions. In part 5, we estimate the equation from part 3 using the last period's delta execution as an IV for the current delta execution. Assume that delta unemployment is exogenous, how do your conclusions change from Park 3? The estimate is similar to that using the first differencing method. If we employ the instrumental variables two-stage least squares method to the first differencing equation, the standard error becomes larger and the estimate becomes statistically insignificant. The endogeneity test shows no evidence that the current delta execution is endogenous. The IV method is not necessary after the first differencing. Thank you so much for doing the computer exercises with me. See you tomorrow. Thank you for watching this video and subscribing to my YouTube channel. See you next time.